Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. I'm just recording this video to give you the correction for the first and the second midterm. Let's start by the first exercise and the first midterm. So the first exercise is series calculations. These are three examples of classical series calculations using classical summing using for or while loops. So it is obvious if you have a finite sum that you will do a for loop. In these two second cases, you will do a while loop because you have an infinite recursive relations. So let's start by the first expression 1, and we have to save it in this name, exercise 1am. Okay, I will copy this, copy. I will go to MATLAB, edit. I will save this as, so I will go to its correction, and I will give this name. So even when you don't give an extension, MATLAB will affect the extension.m for your file. So I start rapidly by clear all, close all, CLC. So I want to calculate the sum of -1 exponent n divided by n, going from 1 to 5,000. So I will write like this. This is the sum. I put it as a comment. Okay. Comment. Sum from n going from 1 to 5,000 of what? Of -1 exponent n, okay, and divided by n, okay. So to do so, I will put n equal to 5,000. Next, I will write my sum initially equal to 0. Let's write something like for small n going from 1 to big N. Wait, big N. Okay. S is equal to the old value taken by S plus -1 -1 exponent n and divided by n. Okay. So in this case, MATLAB will accumulate for you the value of this sum. So I save, I run. You can do it in a different ways. Okay. This is your sum base. So this is. So if you go to big values, you will find the infinite value of this alternate set. So I am calculating. We can do it differently, by the way. We can do it differently, not like this. We can define vectors x, which is equal to x of n is equal to -1 exponent n, and I calculate the sum. Second method, can do it like this. Okay. Oops. Wait. I have to restart. This is a problem. Yes, I will save. This is a problem with the Ultra HD. With Ultra HD computers, problem of number of pixels. So when you reduce, you have a problem automatically. Second method. Oh, shit. wait. So this is my script. Okay. So we say it. We'll do it like this. Second method. Okay. For the second method, I can define a vector x. Okay. And I write like something like for n going from 1 to big N, x of n is equal to minus 1 exponent n divided by n. So SS is sum of x, of the elements of x. So you can do it like this. If you run, you have the same result. These are two ways. So you have S, you have SS, and you have the same result. This is for your exercise 1. Okay. Now for the exercise, for the question number B. B, as you see it, you have square root of 3 plus square root of 3. So if I take a white page, Ctrl New, I can explain for you. That is very simple. So in fact, the idea is very simple. You will do something like a recursive approach. You will do something like I want to calculate this squared of 3, and this result you will take it. This is the first step. You will take it to calculate the square root of, I will call it this method, for example, x1 equal to square root 3, and I will calculate square root of 3 plus x1, and this result I will call it, for example, x2. And I would calculate the square root of 3 plus x2. I will call it, okay, and so on, x4 is the square root of x3 plus x2, okay, plus x3, and it, like this we create a succession. So if you look, for example, for x4, it is like this. X4, it is this quantity, and it is also equal to this. And if you replace x4 is equal to plus x3, and the x3 is equal to this plus x2, okay, and the x2 is equal to what? If you replace x2 by its values, it is, wait, it is equal to, and you replace x2 by its value, and you have something like this, okay, plus x1, or x1 is equal to what? It is equal to square root of 3. So if you go and you increment n to the infinity, and for us infinity is always a while loop, you will have this this form, this infinite form. Okay, so it is very simple. We will write here save as, I will call it exercise 2, exercise 1b, as it is in the exam. I delete all this, and I would calculate this cell. So I would write like this: x1 is equal to squared 3 squared 3, okay, x2 is equal to squared of 3 plus x1, okay, this is done. Then you have to create a certain form of loop until you get convergence. It means you have an error of 10 exponent minus 6. I have to go here, I write my epsilon, which is equal to 10 exponent minus 6. I can take a first error. I calculate my error, or I can do it maybe while perhaps x2 minus x1, and this gap is bigger, bigger than epsilon. You do your work. You do your work. It means you have to calculate again and again n equal to n plus 1. Here you have n equal to 1. Okay? You will do n. So if you do it like this, you will write here xn plus 1. Here xn, because we have n equal to 1, so we don't have any problem. Here n equal to n plus 1. And here x n plus 1 is equal to x n plus, oh, I made a mistake, equal to 3 plus xn. And at the end, the result is x of the last value, x of n. Okay, let's run. We run this. So this is your result. So if you make result exponent 2, you get 5.3. Maybe we have an error somewhere. So it is like this. So when you do it like this, you have the full score. Now I would like to save as and to solve the question number C. Save. For the question number C, you have alternate values. So if you have alternate something, you have obligatory minus 1 exponent n divided by n or something like this. So we can go here and write for the, we have as values, we have 1 minus 1 divided by 3 plus 1 divided by 5 minus 1 divided by 7 plus 1 divided by 9, etc. to infinity. So it's a while loop. So x1, I will write that the first value for x is equal to 1. Okay. here I will write for for the we have -1 divided by 3, okay, and you have to create this kind of sum, infinite sum, okay, because here we have a sum, okay, which is a difference between this and this. Here this is a succession, and here you have a sum. Here you have a sum with a finite upper bounds and lower bounds. The upper and lower bounds are known. Here they are not known, and here you have ampere values. So you have to take care of this. So I would come here. I would define my sum S, okay, equal to initially to maybe I change this. It is better to do this. My sum S equal to maybe S1 is equal to 1, S2 is equal to S1 minus 1 divided by 3. I put n equal to 1, okay. Here I would like to write S, okay. N is equal to n plus 1. I would like to calculate S3, okay. S3, Sn plus 1. Here n equal 1 to S2 minus S1. They are both known. Sn plus 1 is equal to Sn, okay. And here you have to create this kind of recurrence. So if we want to create this recurrence, we have to look here. Here you can write it differently as plus -1 exponent 1, which is equal to -1, divided by 3, which is equal to what? 2 cross 1 plus 1. Okay? This is correct. So I have to create, I have to generalize this. So S1 plus 1 is equal to Sn. I want to generalize this. Plus copy paste -1 exponent n to n plus 1. Let's try it. So if you have, let's try it here. So S is equal to S, result, the final result is equal to S result, final result is equal to S of the last iteration. Okay? So save this. So let's try it in draft. So first of all, you have S is equal to 1. You have 1. S of 2 is equal S1 plus this quantity. Means 1 divided by 3. If you if it is bigger than epsilon, n is equal to n plus 1, becomes n equal to 2. So S3 is equal to S2 plus -1 exponent 2, which is equal to 1 divided by 5. Means plus 1 divided by 5. But after n is equal to n plus 1, it becomes n equal to 3. S4 is equal to S3 plus -1 exponent 3, which is equal to what? -1 divided by 2 cross 3 plus 1. It means -1 divided by 7. So this means that it works. Okay? The script works. So we just run the script, okay? And we get the result. This is our result. Okay? By the way, if you do it analytically, I don't know if it is not it's not demanded, but we can try it. We can try it if you do it. For example, same sum, and you calculate this sum of alternate values, of -1 exponent n divided by 2n plus 1 from n going from 0 to infinity, you will get this result. We can try it if you want, but it's not demanded by. You can write that here, -1 -1 exponent n divided by 2n plus 1, 2n plus 1, okay, from 0 to infinity, okay. If before this, to define symbolic value seems n, okay. If you calculate this sum, so if you calculate pi divided by 4, because here it is symbolic, it will give you this value, which is equal to the numerical value given by our algorithm. So it means that we are okay. Okay, thank you very much. This is the first exercise. Okay.